All right. This is going to be a short video just to review how to integrate using partial fraction decomposition. Get my pen, make sure it works. Smiley face in the corner. Okay. So again, goal of this video, we want to use partial fraction decomposition to evaluate an indefinite integral. So I'm not putting any bounds on this integral, which means we're going to have to remember to include our plus c at the end. Looking at the integral, it's very possible and most likely in the course you're taking, the problem probably will not say use partial fraction decomposition to evaluate this integral. So looking at it, how do I know that that's going to be the strategy? First and foremost, I don't know a function that has this specific derivative. I look at that, I have no idea what function I would need to take the derivative of to get 1 over x squared minus 8x plus 12. There's no obvious u substitution. If I was to let u equal the denominator, the problem is when I take du, I'm still going to have x's left over. I'm going to have 2x minus 8 dx, and I notice that the numerator has no extra x's left over. So trial and error wise, that shows me it doesn't work. Now, what really gives it away though is this. The denominator has a degree that is 2 bigger than the degree of the numerator, and the denominator factors. Those are the clues that allow me to know this is going to be a partial fraction decomposition. So again, first and foremost, degree of the denominator is 2 larger than the degree of the numerator. That's one clue. That's not always going to lead to partial fraction decomposition. It could also be a trig substitution. It could be a problem where you need to complete the square. So the second condition that cues me in that this is a partial fraction decomposition is that x squared minus 8x plus 12 factors. So to approach this, what I'm going to do, first step, is I'm going to find the partial fraction decomposition of the fraction inside the integral, the integrand. So I'm going to write my integrand as 1 over, I'm going to factor x squared minus 8x plus 12. That would be x minus 6 times x minus 2. And what we're doing is we're trying to split it apart into the 2 individual fractions that would have produced this quotient. So it's going to be some constant a over the factor x minus 6 plus some constant b over the factor x minus 2. I'm going to multiply by the common denominator. So this one needs an x minus 2, which means the numerator also needs an x minus 2. This one needs, let's do green. This one needs an x minus 6. This one needs an x minus 6, which means the numerator also needs an x minus 6. So writing both sides, I get 1 over x minus 6 times x minus 2 equals a times x minus 2. And I'm going to make this all one numerator since I have a common denominator on the right-hand side now. So now what I notice is that the 2 denominators are exactly the same. So what this really amounts to is equating the 2 numerators together. I don't even need to look at the denominators anymore. I can just look at the top. So scrolling down, I'm going to solve this equation. A times x minus 2 plus b times x minus 6 equals 1. The simplest way of doing this is to figure out the 2 x values that would make the a and b terms disappear from the problem. So for example, if I look at the first factor, x minus 2, if I was to let x equal 2, what would happen is the a coefficient would disappear from the problem because I would have a times 2 minus 2 plus b times x minus 6 equals 1. That would give me 0. So I can solve for b. And I should actually plug in my 2 for x there, sorry. So everywhere I see x, I'm replacing x with 2. So this would give me negative 4b equals 1. Tells me that b would have to be negative 1/4. Similarly, if I look at the second factor, if I let x equal 6, the second term is going to drop out from the problem. I'm going to get a times 6 minus 2 plus b times 6 minus 6. That's 0. That's gone. Equals 1. So what that gives me is that 4a equals 1, which means that a has to be 1/4. Not done with the problem, but going back up to the partial fraction decomposition, what that tells me Go back up here. What that tells me is I can write the original function, write it over here. We had 1 over x squared minus 8x plus 12. That was a over x minus 6. We just figured out a was 1/4. So that's 1/4 over x minus 6 plus b over x minus 2. And we just figured out b was negative 1/4. So this would be plus negative 1/4 over x minus 2. This right here is what I'm going to rewrite as the integrand, because this is going to be a lot easier to integrate. So going back to our original integral, we were given 1 over x squared minus 8x plus 12 dx. And so what I'm going to do is I'm going to write that as the integral of a, which was 1/4 over x minus 6, plus negative 1/4 or minus 1/4 over, the other one was x minus 2. I'm going to put this in a giant set of parentheses, dx. I'm going to pull the 1/4 out front. So coming over here, this gives me 1/4 times the integral of 1 over x minus 6 plus, minus 1 over x minus 2 dx. Okay, now comparing, why did we do this? Because if you go back to the original function, what we mentioned was that this right here, this 1 over x squared minus 8x plus 12, I have no idea how to take an antiderivative in that form. However, we took this particular integrand, go back down to the bottom, and we rewrote it in an identical form. 1 over x minus 6 minus 1 over x minus 2. I know an antiderivative for 1 over x minus 6, and I know an antiderivative of 1 over x minus 2. So the partial fraction decomposition makes it simpler to be able to take an antiderivative of each piece. This would be 1/4. The antiderivative, or the integral of 1 over x minus 6, would be the natural log of the absolute value of x minus 6, minus the antiderivative, or the integral of 1 over x minus 2, would be the natural log of the absolute value of x minus 2. Don't forget your plus c. This was an indefinite integral. This is a perfectly acceptable way to leave your answer. For those of you who are in AP Calc BC, the College Board might have some multiple choice questions where it is not left in this format. So you should be able to look at the portion of this answer that deals with the natural logarithms and realize, oh, subtraction of logs would switch to division. So an identical form that you might see on a multiple choice question would be 1/4 times the natural log of absolute value x minus 6 over x minus 2. Subtracting 2 logs turns into 1 logarithm as long as you switch to division. But on a short answer question, feel free to leave it as I did before. So either one of these would be an acceptable solution and would give you an antiderivative, which evaluates the indefinite integral that we started with. Hopefully you found this video helpful and can use it for future integrals that you may encounter.